Question number 27. Which species is produced during a propagation step during the reaction of propane with an excess of chlorine in the presence of UV light? So the first step, the initiation step, will be that the chlorine will produce two chlorine radicals, two Cl dots. So don't be confused by that. The Cl dot then reacts with the propane and will substitute itself for one of the H's. So it's definitely not a H dot. I mean, you make HCl during the propagation step, but you never make H dot. It's not this, so you're going to get some kind of substitution of the H's with Cl's, but this might be formed in a termination step where two radicals come together to make a longer carbon chain. So it's not that one. It's between B and C where H's have been substituted. Now, if you actually look at with B, C3H5Cl, you've introduced a double bond, so it's not got a double bond introduced in there. It's got to be C, where some Cl's are replacing some of the H's. Which compound forms a racemic mixture when reacted with KCN followed by a dilute acid? Well, let's do spoilers on this. So you're looking for the Cn minus from the KCN, the Cn minus, the lone pair on the carbon attacking the carbon of the carbonyl compound. So where the C double bond O is, the Cn minus will attack the C, and the double bond between the carbon and the oxygen will break. Electron pair will go onto the O, leaving a single bond, and then when it reacts with something like dilute acid, the H plus will react and turn the O minus with a lone pair of electrons attacking the H plus to make OH. So this C double bond O will become a CCN and an OH minus. But we've got to work out which one it is then. So A, incorrect, because you're going to get CH2 CNOH. So this C double bond O there, the C double bond O will become C with an CN and an OH, but there's two H's there on the C, so you've not got a chiral carbon in there, so you can't get a racemic mixture of two different enantiomers because you've not got a chiral carbon. B is a possibility. We think B is correct, so we'll have a look at that in a minute. This one won't have a chiral carbon because the CO will become an OH with a CN on the C, but you've got two methyl groups either side, so no chiral carbon, and again no chiral carbon on this because the C double bond O becomes an OH with a CN, but you've got two ethyl groups. So the answer is B. Let's just check B out. It's planar, so what will happen is there'll be an equal chance of the CN attacking from above or below to make two different enantiomers, and the CH will become, so the CO will become a COH with a CN, so that C will have an OH, a CN, an H and a methyl group. Your answer